All right, welcome to the explainer. I want you to just take a second and imagine that you're looking at a screen cascading with green code. You know the exact visual I'm talking about, right? Well, right now, when you look at a Cambridge computer science past paper, specifically syllabus 9618, you probably just see this chaotic, overwhelming wall of questions. But here's the secret. There is no paper. There are only patterns. Today, we are completely decoding the hidden structural frameworks behind this exam, and we're zeroing in on a notoriously tricky topic: antivirus software and anti-spyware. Listen, surface level knowledge just won't cut it anymore. If you want to ace this, you literally have to learn to see the code behind the question.
So let me ask you something. Are you working incredibly hard, maybe reading the textbook from cover to cover, but somehow you're still losing easy marks? Trust me, it is incredibly frustrating. You sit there in the exam hall, you see a prompt asking you to evaluate complex antivirus heuristic analysis, and your mind just goes totally blank. You freeze. Or maybe you write half a page of what you think is gold, but the examiner gives you a brutal 2 out of 6. Why does that happen? Well, it's usually because you're relying on raw facts, when what the examiner is actually looking for is a specific analytical framework. Okay, let's dive into this. Here is our structured roadmap for today's explainer, and I promise we are going to decode the entire exam system step by step. First, we have the examiner's reality. Second, decoding core principles. Third, the procedural framework. Fourth, critical examiner warnings. And finally, number 5, the method mark strategy. Kicking things off with Section 1, the examiner's reality. To master this exam, you have to understand the specific cognitive domains the examiner is testing. Let's look at 2 deeply flawed student approaches to a typical 8-mark question on how antivirus software detects new threats. First, there's Alex. Now, Alex overloads the page with raw facts, stuff like the history of malware, dictionary definitions of Trojans, basically providing superficial breadth, but absolutely zero analytical depth. Then on the flip side, we have Sam. Now, Sam is smart, but Sam rushes. The question explicitly commands evaluate, but Sam just describes, totally missing the boundary conditions and edge cases. Cramming technical data like Alex or ignoring the command word like Sam is pretty much the fastest way to sabotage your own score. Moving right along to Section 2, decoding core principles. Because the assessment framework always prioritizes analytical depth over superficial breadth. Okay, this right here is the technical blueprint that top-scoring candidates actually use. It's called the PEAL framework. That stands for point, evidence, explanation, link. Instead of just rambling on the page, you make a specific point. For example, anti-spyware utilizes real-time behavioral monitoring. Then you hit them with evidence. It scans active system memory for unauthorized keystroke logging. Next comes the explanation. Unlike traditional viruses, spyware masks itself as a legitimate background process to avoid signature detection. And finally, you link it back. Therefore, behavioral monitoring provides a critical defensive layer against zero-day data exfiltration. See what we did there? It's a highly systematic method to build real analytical depth. Now, check out this insider secret straight from the Principal Examiner report. They literally say, candidates referencing cross-topic connections achieve significantly higher marks. This is absolutely crucial. Don't let antivirus software exist in a vacuum in your brain. You have to connect it. How does malware actually impact memory management? How does a virus alter a binary file structure or disrupt network packet transmission? Integrating these concepts across the syllabus is a guaranteed mark booster because it proves master-level understanding. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, getting back into the strategy, Section 3, the procedural framework. This is where we learn to process abstract benchmarks into a real, actionable checklist. Whenever you're facing a really complex scenario, you absolutely must process it systematically. Here's how you do it. Step 1. Identify the key elements, like what exactly is the threat context here? Step 2. Apply relevant principles. Are we looking at a signature-based issue or a heuristic issue? Step 3. Execute the analysis, which might mean extracting data from binary representations. Step 4. Verify for reasonableness. And Step 5. Present your findings using exact, precise terminology. Walking through this standardized sequence transforms pure guesswork into engineered perfection. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's launch into Section 4, Critical Examiner Warnings. It's time to face the harsh reality of why students really lose marks. And this brilliantly illustrates what we've been talking about. Straight from the source, here are the top 3 examiner warnings. Number 1, vague answers. Writing something like antivirus stops bad files is totally amateur. Examiners want specifics. They want to hear about isolating executable code in a sandbox or comparing file checksums against a threat database. Number 2, forgetting boundary conditions. Think about it. When you're tracing how an antivirus scans a drive, what actually happens if the drive is totally full? Or what if the file is encrypted? Those are edge cases. And number 3, ignoring context. If the prompt specifically talks about a corporate network, a generic answer about a home PC is going to fail. You have to adapt. This all builds into a really critical workflow: deconstruct, solve, and evaluate. Consider this highly flawed statement. Anti-spyware and antivirus are the same because they both scan the computer. Well, the evaluation phase exposes how wrong that is immediately. Real comparative analysis requires you to contrast their core functions. Anti-spyware specifically targets data-gathering software and network transmission behaviors, whereas antivirus targets self-replicating malicious code that fundamentally corrupts files. You must evaluate these differences and justify your decisions with hard technical evidence. Which brings us to the ultimate safety net. Section 5, the method mark strategy. So in Cambridge computer science exams, there is this incredible safety net, the method mark strategy. Basically, marks are awarded for demonstrating the correct analytical and procedural steps, even if your final mathematical or logical answer is entirely incorrect. Examiners genuinely want to reward your algorithmic thinking and your step-by-step decomposition. So if you extract data from a binary string to identify a malware signature, and you just happen to make a tiny arithmetic error on the very last bit, you don't lose everything. You still earn marks for the logical process you showed. But listen to me. That safety net only applies if you follow one absolute golden rule. Always show you're working. I cannot stress this forcefully enough. When you're performing calculations, tracing algorithms, or extracting hex values, you have to document every single step. Clear notation and correct terminology are your absolute best friends here. If your logic is sound, showing you're working will literally save your grade. To bring this whole explainer together, here is your definitive success blueprint. 3 absolute rules that basically guarantee top marks if you follow them. Rule 1, command word decoding. You have to know the exact specific difference between describe, explain, and evaluate. Rule 2, Peel framework application. Every complex answer requires a point, evidence, explanation, and link. No exceptions. And Rule 3, time management matrix. Allocate your time strictly based on the mark value of the question, ensuring you leave yourself enough time to verify your answers for reasonableness. Students who implement these strategies see an average improvement of 2 grade boundaries. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCS and click that bell. Don't let another exam pass you by. So, as we wrap up, I want to leave you with this one thought. If a totally new piece of malware is completely polymorphic, meaning it's constantly altering its own binary signature to evade detection, how exactly would your current system's heuristic analysis adapt to stop it before the damage is done? Understanding that answer is the true key to mastering the matrix of 9618. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.